Okay, so this topic that I'm going to be covering will be laws of indices and logarithms. And I'm going to cover this topic in the course of 2 videos. First, I'm going to start with the laws of indices, and then in the next video, I'm going to talk about logarithms. I know logarithms is a very complicated topic at times, so it's very important for you to understand your laws of indices in order for you to really grasp logarithms. Now, first of all, let's talk about exponential expressions and what exactly is an exponential expression. I have a definition here. I said that an exponential expression is of the form a to the x, where a, at bottom there, is called the base, and x is called my exponent, or we can also refer to it as the index or the power. Now, for example, if I had x raised to the third power, I know that my base is going to be x and my index is going to be 3. Now, what exactly does this index mean, or called the exponent? Well, it's simply telling me to multiply my base a specific number of times. So for example, for this guy right here, x cubed, I'm going to multiply x 3 times. That's basically what it means, right? Let's talk about the laws of indices now. Now, when multiplying exponential expressions of the same base, we keep the base and we add the exponents, right? So for example, if I had 3 squared times 3 raised to the 4th power, I'm going to keep the base, which is 3. I'm going to add the exponents, which is 2 plus 4. That's equal to 3 raised to the power of 6. Okay, now why do we add the exponents? Well, if you look at it this way, what is 3 squared? 3 squared is 3 multiplied by 3. And what is 3 to the 4th power? Well, 3 to the 4th power is 3 multiplied by 3 multiplied by 3 multiplied by 3. Right? And if we're going to multiply these two guys together, how many times are we multiplying 3 in total? 6 times, right? 1, 2, 3, 4, 5, 6. Right? And that's equal to 3 raised to the power of 6. All right. Let's say we had something else. X cubed times x squared times x to the 4th. Again, this is the same concept. We keep the base, we add the powers. It's going to be 3 plus 2 plus 4, which is going to be equal to x raised to the power of 9. Now for this guy right here, let me just draw a line here, separating it. Yeah. For this guy right here, I have 2 exponential terms with the same base, and one of them is the odd one out, right? So what I want to do, I want to group my exponential terms with the same base. So I have x squared times x cubed times y cubed. Now I'm going to apply my product law. So what do? When multiplying and the bases are the same, I keep the base and I add the powers. That's going to be equal to x raised to the 5th power times y cubed. All right, let's move on to the next one. Now this is the division law. Now when dividing exponential terms with the same base, we keep the base and we subtract the bottom exponent from the top. That is the top exponent minus the bottom exponent. So for example, if I had 4 raised to the power of 6 divided by 4 squared, what am I going to do? I'm going to keep the base, which is 4. I'm going to subtract the bottom exponent from the top exponent. Basically, it's going to be 6 minus 2, which is equal to 4 raised to the power of 4. And 4 raised to the power of 4, that's going to be equal to 256. All right, let's say we had x raised to the power of 3 divided by x raised to the power of 5. Well, what do? I keep the base, and remember, top exponent minus the bottom exponent. This is going to be 3 minus 5, which is going to be equal to x raised to the power of minus 2. And what do we do when we have an exponential expression being raised to another exponent? Right? Now, we simply keep the base and multiply the exponents. So if I have 5 raised to the third power, all being raised to the second power, that's going to be equal to 5 raised to the power of 3 times 2, which is equal to 5 raised to the power of 6. All right. Now, what do we do when we have negative powers and we want to express it into something else? Well, we simply put the exponential expression under 1 and we change the power to a positive power. Just like what we did over here. So for an example, if I have x raised to the power of minus 4, that's going to be the same as, what do? Put the expression under 1 and we change the power to a positive. Simply 1, that's going to be 1 over x to the 4th. And same thing here. 6 raised to the power of minus 3 is going to be 1 over 6 cubed. All right. Let's move on to the next one. The fact that anything raised to the power of 0 is 1. So if I have 3 raised to the power of 0, it's going to be 1. If I have anything raised to the power of 0, it's going to be 1. Let's understand why that is the case. Well, you agree that 9 over 9 is equal to 1. But how else can I express 9? I can express 9 as 3 squared. So 9 over 9 is the same as 3 squared over 3 squared. And what do I do when I'm dividing exponential terms with the same base? I subtract the powers, right? I keep the base, which is 3, subtract the powers, which is 2. That's going to be equal to 3 raised to what power? 0, which is equal to 1. So now you can actually understand why anything raised to the power of 0 is 1. All right. Now, what about expressing exponential terms with fractional powers? Well, it's simple. We're going to use our root symbol, but the denominator of our exponent, which is that bottom number, that this bottom expression, this bottom value right there, that's going to be the root. Just like how the bottom of the tree is the root, right? So if I have 8 raised to the power of 1/3, that's going to be the cube root of 8. So that 3 is my root. All right. What if I have a fractional power now, where my numerator is probably not 1? Well, same concept applies. The bottom, that denominator right there, that's going to be the root, right? So if I have 9 raised to the power of 3 over 5, that's going to be the 5th root of 9 raised to the 3rd power. Okay, what if I have 3 raised to the power of 3 over 2? That's going to be the square root of 3 raised to the 3rd power. Now you're probably wondering why I did not write it in 2. Well, that is because this symbol represents square root by default. So you don't need to write in that 2. Okay, what about if I had y raised to the power of 4 upon 3? Again, same concept, the cube root of y raised to the power of 4. Okay, so here we have the product of 2 exponential expressions with different bases, and we're raising everything to another power. Well, we simply distribute that outer exponent. Distribute. So in this case, we're going to get a raised to the power of mp times b raised to the power of np. So for an example, if I had x squared times y cubed, all being raised to the power of 4, this is going to be equal to x raised to the power of 2 times 4 multiplied by y raised to the power of 3 times 4. Again, distribute, right? So that's going to be equal to x raised to the power of 8 times y raised to the power of 12. All right, now this is a common mistake. A lot of people might say, well, a raised to the power of m plus b to the power of n, all raised to this outer power here is going to give me this here. That's not true. Why? Because we're adding here. See that we're adding? And up here, where the law applies, we're multiplying. Be very careful. Okay. So for the other one, Here we're dividing two exponential expressions with different bases, and we're raising our quotient to another power, right? So let's say I had 5 raised to the 4th power over 2 raised to the 6th power all raised to the 3rd power. What do? I distribute my power. It's just like how I distributed it when I'm multiplying, right? So it's going to be equal to 5 raised to the power of 4 times 3 over 2 raised to the power of 6 times 3, which is going to be equal to 5 raised to the power of 12 divided by 2 raised to the power of 18. So if I have y cubed over x to the 4th, all being raised to, let's say, the 2nd power, is going to be equal to, remember, distribute, y raised to the power of 3 times 2 divided by x raised to the power of 4 times 2. That's going to be equal to y raised to the power of 6 divided by x raised to the power of 8. Okay. Now, what if I have an exponential expression with a fractional power that's negative? Well, what do we do when our power is negative? Well, we take the exponential expression, we put it under 1, and we make the power positive. Okay, now how do we express an exponential expression with a fractional power? Well, again, same thing. The bottom is the root, so n right there, and the m at the top, I'm going to raise my base to that power. So a raised to the power of m. So if I had 4 raised to the power of minus 3 over 2, that's going to be equal to what? 1 over 4 raised to the power of 3 over 2, which is going to be equal to 1 over the square root. Again, the root, the bottom, right? 1 divided by the square root of 4 raised to the 3rd power. Right? What if I had x raised to the power of minus 5 over 3? Well, that's going to be the cube root. Sorry. What do we do first? We put it on the 1. Make the power positive. It's going to be equal to 1 over the cube root of x to the 5th power. Alright guys, that's going to be it for laws of indices for now. And in the next video, I'm going to cover logarithms and the laws of logarithms.